Good morning.
Good morning, everyone. Welcome to our session. I hope you have had a nice, good night's sleep and you're all fresh now. My name is Nour Ramzy and I work as a knowledge engineer at eccenca. And together,
With Marcel Fröhlich, I run customer projects at eccenca, and we're happy to introduce a new concept, a new component that is upcoming in our product, and we think it's a good one. So we wanted to give you a glimpse of what's coming to have time to prepare yourself.
before we get started, let me tell you a little story. I live in Munich, and while organizing myself to come to Leipzig by train, one of my colleagues asked me, when are you expecting to arrive in Leipzig? Which sounds like a simple question, but it was not actually a simple question to answer. The answer had to be manifold. The first part was, I expect to arrive at 12, but in reality, I cannot give you any concrete answer. We'll just have to wait and see. And I don't even know if the train conductor can give you a solid answer on this. And end of the day, I managed to arrive on time. I was only a couple of minutes late while the train application was still showing the original arrival time. So all worked out fine, but the point of my story being that we live in a world where speed matters, but not only speed matters. Precision matters, accuracy matters, and above all, trust in the system matters more. Okay? Especially when it comes to technology. AI feels like a high-speed train nowadays. It's moving at unprecedented speed, and that's what the Gartner cycle... Let me test this first. Yes, and that's what the Gartner cycle is showing us, that the AI technologies are moving at unprecedented speed now. Organizations are moving forward from testing, experimenting, to full adoption mode on. But again, similarly to my story, speed is not the problem with AI. Building models is no longer the challenge. The challenge now becomes building models that people can trust. Building models that give you answers that you can blindly rely on. And with this also, the Gartner cycle is showing us some other technologies that are now in this phase that we call
Slope of enlightenment.
slope of enlightenment, where you see the green box. And one of these technologies is knowledge graphs. The slope of enlightenment phase is basically the phase where technologies, after being in the hype, they are finding their own use and their true benefits to being used in real world problem. It's no longer a hype and everyone excited, but they are really being used to resolve and solve some complex problems in the real world. And amongst these technologies is the knowledge graphs. So knowledge graphs are now being regarded and looked at as enabling technologies for AI. But what does that mean? When we say enterprise knowledge graphs are enabler for AI, first of all, what is an enterprise knowledge graph? Just a refresher for some of us. When you say an enterprise knowledge graph, you combine two main things. The first thing is you combine a semantic model, so what we also refer to as an ontology. So a representation of your domain, how concepts are defined in the domain, how they are related together in this domain. And the second part of an enterprise knowledge graph is your data, which is very important, but within the context of an enterprise knowledge graph, your data is ground and bound and aligned to an ontology model. So it's not just data scattered everywhere, but it is relevant and aligned to this semantic model. But what does this bring to us? Why are enterprise knowledge graph enabler? The first thing that an enterprise knowledge graph brings us is semantics. So semantics, you probably heard this word before, but just to refresh, it's basically the literal definition of a word. So a very simple example could be a plane, is also a Flugzeug, is also an avion, and the literal definition of something like this is that it's a flat surface. Okay? So within an enterprise knowledge graph, you get the semantics of a word. What do you get as well? You get context. Okay, so context is basically changing depending on who you are, depending on where you are. When you have an enterprise knowledge graph, you introduce a context. So for example, back to the plane, a plane for a physicist is something that generates lift. For a kid, it's something that has wings and flies. But for an airline company, it's something that transports either people or cargo. Okay, so within your enterprise knowledge graph, you also bring in the context. One more thing that enterprise knowledge graphs bring is reasoning. So reasoning is basically the capability to infer new knowledge that does not explicitly exist in your data. Another simple example with the plane. So you define in your semantics and in your context that a plane has a wing, and then you also have a physical object, something that you, let's call it plane A, and you know that this plane A is a plane. Then what the new inferred knowledge could be that a plane A has a wing. Why does this bring us anything beneficial? Because then you can use or take care of this plane A, that is the physical object, accordingly that it's something that has wings and thus needs certain types of maintenance, certain measurements, whatever. So this sort of inferred knowledge is added to your existing knowledge. Last but not least, the fair representation of data that is guaranteed once you have enterprise knowledge graph. And fair basically means that your data becomes findable, accessible, interoperable, and reusable. So putting all of this together, we can say that knowledge graphs enable AI by providing the semantics, first of all, because models can now use the concept not as isolated concepts and isolated terminology, but as in relation to other concepts. Also, when you bring context for AI, context reduces ambiguity because answers will be relevant to who you are, where you are, and what you're doing. As well as the fair representation of enterprise, it can ensure that you have sound and high quality AI systems that with the data that you have. And last but not least, with reasoning, this new inferred knowledge can be used by AI as facts. So you introduce new facts to your models. And then one important point to mention is explainability, because if you rely on enterprise knowledge graphs to enable AI, you can also trace back the reasoning path to understand why the model is saying something like that, not just what it says, but why it says. So you can trace back the answer and the reasoning logic of how the model reached a certain answer, and this overall can generate some trust in the model. Okay, now that we've established that knowledge graphs are relevant these days and are enabler for AI, how does an enterprise knowledge graph process generally looks like? How do we build a knowledge graph? First of all, you start by looking into your data. You get familiar with your data, you start understanding the domain better and better based on the data. Second step is that you start building an ontology, which is the semantic model. Third step is that you map the data to the ontology so that, like I said earlier, so that the data is aligned to your semantic model. Once you have done the mapping and you understood the data and you built your semantic ontology, you basically have your enterprise knowledge graph created that you show to experts and show to people that will use this knowledge graph, and accordingly you decide to iterate over and over to gradually expand the model, gradually add more data, and so on. This process flow works well for so long. However, what we're seeing these days in projects is that, let's say another part of the organization hears about the semantic approach and hears about enterprise knowledge graphs and is interested in something similar. What would they do? They would start looking at their own data, building their own pipelines, looking at building their own ontology, and we start having these custom and niche bits of works that are independent within one organization. So let's say, and let's try to agree that this process of creating a knowledge graph worked well for so long, but now that the approach is getting more popular, it's not really scaling up and could even lead to sometimes incompatible models within one organization. Okay? And maybe, Marcel, you have a few additional points on how projects generally work on this iteration process?
The shift that we're currently seeing is going away from individual solution-oriented knowledge graphs towards more an idea of infrastructure as presented on the slide before. So the challenge is now very much a challenge of how can we create many knowledge graphs and still have those being developed independently, so you don't want everybody to align with everybody else, even though they have points of contact or overlap in the data. So two things to consider. Obviously, you need to sort out governance right from the start, how you want to build things, what are the design rationale and guidelines of how you build knowledge graph. And then obviously key is to have experts talk to each other. So experts also from those domains that have overlap in their scopes. Because the reality, and this is why it's a circle, in the beginning it always looks pretty straightforward. So everybody thinks, yeah, our data, no problem, we get it, we know what it means. As soon as these discussion starts, in the beginning still everybody thinks, yeah, everybody else thinks the same way than I think. Only over time, when you're already sort of knee-deep into modeling and edge cases show up, people start to realize that they do not have the same conceptualization, the same opinion on edge cases, on how things actually should be. So, and this is where things start to get interesting and where the real work starts of aligning, of deciding where to go, how to define these things, where to introduce new abstractions, how to make sure that the perspective from one department can be clearly aligned with another department's perspective, which does not mean that one wins. It's not about one size fits all. It's about making sure that those different points that they make, they all have their different models for a reason, that they can be reconciled in a rational way, and that even in edge cases, everyone is clear about how to resolve these. And that's what Semantic brings. It brings a mechanism to represent the outcome of these discussions. Because you don't want to start this discussion all over again, potentially with different outcomes each time, which is the case as of now. Large organizations on average have, I think, approximately one system per 10 employees. So look at large organizations, it's huge. They have so many systems, and each of them was probably developed as a project running very much on their own, making up their own decisions about designs of databases and whatnot. Obviously, it's not all lost. These organizations work, so there is naturally coherence in there. But there's still lots of edge cases where things easily break. I mean, this whole software category of process mining wouldn't exist if there weren't all those glitches in the processes, and naturally that also means glitches in how data models and ontologies implicitly match to each other or not. So.
Basically, so to recap, as AI is accelerating and we know that knowledge graphs can be used as enablers, we need knowledge graphs to scale up as fast, and we need to look and start looking at the process of creating knowledge graphs differently. And so what about if we start operating like a production line? When production lines were introduced years ago, they had a few benefits that they brought. First of all, they brought standardization of manufacturing steps. You have, in a specific step, you do one thing, and then in the following step, you do another thing. And the interface between these two steps was also standardized in production line. So that's one point. Another point is that they automated in production line repetitive tasks so that you don't have to waste time doing or inventing things while the tasks are very much structured and well known. The third thing is that factories started behaving a bit differently. They started being assembling or reusing parts to build one product and one other product that are similar but are both reusing parts. So what if we start looking at knowledge graphs and the process of building knowledge graphs similarly, so that we can start industrializing the engineering process around knowledge and around knowledge graphs? In fact, that's not a brand new idea. Software engineering faced the same paradigm shift, so to say, decades ago, when they moved from handcrafting codes to what you see here, probably very familiar with, only examples of libraries, packages, containers, and so on. So what if we start treating knowledge graphs similarly to software packages, where we can reuse them, reproduce them, and find them easily, and then they can scale? And this is what our main talking point today is about. We want to share with you about semantic packages and how you can use eccenca corporate memory marketplace to package your semantic artifacts, your knowledge graphs, your ontologies, controlled vocabularies, integration pipelines into semantic packages that can be reused and shared across organizations. Marcel, go ahead.
Okay, so that's the main point. We introduce a package management system on the artifacts level, and obviously software as marketplace, or, well, the metaphor is also very close to app store, depending on how you organize these things. And we see immediately so many benefits that we think this is really a major new facet of what our product brings, that we want to introduce it early on. It's already there, it's already working, but obviously there is a roadmap over the next few releases to make this sort of unfold and all the features come in. The very first and obvious thing is about lifecycle management. If we have a means to package all kind of artifacts together, all the deployment and DevOps related things get very much more predictable and easy to organize. So with infrastructures growing up, new obvious demands arise, like spinning up new servers automatically on demand, making sure that complicated dependency resolution needs to take place. A lot of this has been, well, done mostly handcrafted, because most of earlier solutions were focused sort of on one system running reliably and not so much on dynamic deployment patterns. So that is a big win to rationalize and improve the quality of all the automation and installation tasks. The other one, which I think is even more important, is about standardization. So knowledge graph, obviously from the very beginning, is the key idea to standardize, at least on a slightly more abstract level than data models, of the things that are being talked about as data within an organization. That's the whole idea of ontologies. But as we see in our own product, there is many more relevant artifacts around these things. So all those artifacts like knowledge graphs and so on don't come out of the blue. You have processing pipelines, all kinds of abstractions, workflows, mappings, data linking procedures, plugins of all kinds that all need to be put together, bound together, and ideally used repetitively in the same way across the organization. Because if you use, let's say, the same recipes and the same mechanisms to build things, you automatically have more coherence and also an easier life to evolve those software artifacts, because you don't have to change a dozen of them, but maybe just one ideally. So it enables kind of interoperability across different repositories. And if you continue this line of thinking, if you have a repository where specific processing of ontology-grounded things happen, you can also imagine that similarly to microservices in the software world, there is a much higher chance not just of reusing them, but also co-creating them. Think of stuff that happens within a single organization. At least within a single organization, there is a lot of incentives to make things together just to save resources. So if there is a processing component to create a certain kind of data product that different people use, somebody might have a need to extend this, and instead of building this anew, could use the package that already exists, make a branch of it, put the extension inside, share it back to the marketplace, and very likely he's not or she's not the only one in need of this extension or additional feature. So there is a dynamic unfolding that things are sort of being shared and progressed along the structure of what the ontologies give. So we see a tremendous opportunity to improve not only reuse but also shared extensibilities of features of such packages, which we think is really a big one. And this is sort of mock-up of a visual interface. At the moment, it's still sort of implemented on batch level. But the idea is that you can have, the best metaphor that everybody knows is an app store. You can search for certain things, find a list of stuff, and potentially decide to use and install it, basically one-click deployment. We have here built some examples around the demo that we made for police investigation use case. So those packages are not homogeneous. They're not all holding the same stuff. They can hold ontologies, they can hold data products, they can hold technical artifacts like shackle shapes, or a combination of these and have sub-packages be bound together, be dependent on others. That's the kind of vision that you have a shared place where this happens. And the good question is, where does it happen? So obviously from a vendor perspective, we have an incentive to provide at least one central place where stuff that is sort of being considered as open and shareable is accessible to everyone. So we also put a lot of stuff that we develop ourselves in there. We have already built a huge number of plugins that will eventually then also show up in the marketplace. But the more interesting case, at least for the typical customer that we have, which is usually a very large organization, is to think of marketplaces within the organization. If you know how these systems are deployed, how these processes work, it's very unlikely that somebody who's in an enterprise role would be able to just connect to some outside marketplace and fetch anything from there that should be used in a production case. That's not how it works. You probably don't even have an internet connection from this machine. So there is all kind of governance barriers for good reason, I guess. But at least inside an organization, it makes a lot of sense to have such an infrastructure in place. So to share within the domains and even across generic components that do stuff that are better developed together to create one high quality thing than 50 different projects trying to resolve a specific problem all on their own over and over again. So that's the general idea of the semantic packages and the marketplace. And here I have one such thing, which is this investigation package. It's tagged as a data integration project. And there are all kind of things in there. So if you look at the big box at the bottom, there is literally data integration projects in there. There are workflows in there. There are data graphs in there. There are plugins in there. There are vocabularies, ontologies in there. There are shapes in there. So all the artifacts that you need to spin up a sort of knowledge graph solution, and different standardized metadata items like who published it, what is the status, what's the license at the moment, to which version is it compatible, which version of this component is it, when was it least updated, and what has changed. So standard things that you would expect also like in any other kind of repo. And currently, as I said, is being implemented on the shell automation level. So it's accessible via our command line tools. And from the next version on, every sensor corporate memory will also come with a local marketplace accessible. So you don't have to use it, but people who have a sensor corporate memory will at least locally have such a thing in place. And here I have a small demo showing some little things like something is installed, data sets showing up that were not there, project showing up that were not there, functionality showing up that was not there. And let me try to run this. So we look at a sensor corporate memory front end, for those of you who've seen this before. And at the moment, all it basically shows that there is not many graphs in there, just some standard graphs. And it goes to the data integration and there's no project there. Then from the command line, some package is, it first shows what the commands are, then a package is picked and installed. And once the package is installed, we will go back, is it running? And see that there are projects in place. We will see that there are new data sets in place that haven't been there before. That there's also this package was shown as being installed. So new knowledge graph functionality or new knowledge graph artifacts are in there. And the next thing that we show is that this can also be used to add functionality. We have some address data in there, and the address data is currently shown basically just as a bunch of attributes. There is functionality that has been loaded with the plugin that can be activated by a shape to also give a more meaningful representation of the geodata, so not just coordinates as data, but actually showing a map, which was not there before, so the capability to show this map has been installed from the package. And finally, it shows that there are some data sets that have information. There is a resource Leipzig, but there is no information in there. Finally, we also add an import, a dataset import of something that came with the package. And this dataset import has more information about geo-entities in the Saxony region. So the next time we'll jump to the same place, we suddenly see there is now information about Leipzig available. So we go in there at the same place and suddenly it's populated because stuff has been brought in from the package. So straightforward, nothing surprising, but obviously a very powerful mechanism to automate and especially when it comes to automation with AI, this is going to be a big thing. So it's already the recap slide, but before I recap, I want to highlight some more things that we currently see could eventually be done with that. As a general package store, implicitly it is also obviously a data product store or data product marketplace that we bring. Data products at the moment, if you see them, you always have to take a decision, an informed decision, who can have access to that. So at the moment you would probably only share stuff in such an infrastructure that I explained that are at least considered accessible to everyone within the organization that can use the store, which is a start, but it's obviously only that, because eventually you would probably also want to have possibility to describe under which conditions such things would be allowed to use. So maybe not everything is meant to be used and accessed by everyone or for every purpose. So something that we currently build at the OMG, Object Management Group, sort of the standardization body that we're also involved in, where we did the DPROD standard, is also currently working on a policy layer on data products. So at least this is a case where financial service institutions have a large interest in. What they basically want to do is they want to describe policies of data products in a fine-grained way, because many of these data products they just bought from a third party with a complex contract attached to it, which not only says, here's the data, give me money, now do whatever you want, but it usually says, well, you can do certain things with this data that you just license from me, but there's many strings attached, so you can only use it for certain purposes, you can only use it a certain number of times, you must do this, you must not do that, and if you do this, then you also have to do something else, these kind of things. And if we manage to go to a place where we can describe these policies as part, in an ontological way, of data products, we will eventually reach a point where we can then truly, safely, and in a governed way, also give AI agents the capability to discover data products, and the infrastructure take a decision whether for the purpose this data is being searched for is actually covered by the contracts that are in place. So the ideal place eventually from their perspective is to be able to automate this whole process of data discovery and the decision of whether this data can be deployed and is allowed to be used for a certain purpose and in a certain context. And if this is formally covered, this can be automated. That's where we're going. Obviously, this extends to other things as well. So what I just described for data products might be relevant for all the other artifacts that we just introduced as well. So, recap, AI explainability and trust is the key driver why enterprise knowledge graphs are a key enabler for AI. The iterative development is sort of at the heart of the paradigm shift to scale up, and the package management is the idea for the eccenca corporate memory marketplace. As I said, each corporate memory will have a marketplace attached, but it will not be the only one. There might be other marketplaces on different levels of an organizational hierarchy or beyond. It's about governed life cycle, about standardization and efficient reuse, what I introduced in the beginning. And if you want to have a mental picture of what this is all about, think about physical flows. If you think at river flowing along, what you see is sometimes there are like these what's it called, vertices showing up in when the river is not flowing straight. So, and you can see similar things in processes. What you want in your processes, you want them to flow smoothly in your organization. That's the ultimate goal. That's also what the whole process mining is about. If you manage to make all these disturbances go away and have processes typically flow through without exceptions and without manual interference, then on average your whole organization will work as best as it can. And to achieve this smooth flow, you need to have things in sync. And having things in sync means primarily and first having data and models in sync and how things are being processed. So we think, or we very much believe that this is a big contribution to reach that, and will help to automate and further enable to accelerate AI automation and delivery in a way that people can trust. So what does this mean for our customers? It means think about it. Think about creating semantic packages. It's a great way to abstract a lot of detail, knowledge and decisions away and to make things more easily usable. Think about building also an organizational marketplace. It will be absolutely worth it to have a place where these things can be shared, to essentially reach the balance, some equilibrium between innovation on the one hand, improving things, making new things, but also reusing things that are already there and in place. So that's it from our end. Thank you very much for being there. Thank you very much for listening.
Thank you, Nour and Marcel. So we have 5 minutes for questions. Do you have any questions? And if so, please go to one of the microphones. So if you do not have a question, I have a question. Marcel, you briefly mentioned your work in the OMG group. Can you give us a timeline about the policy specification when it's ready to be adapted by industry?
Yes, I can. So looking at the process of the 1.0 spec, which was available for, I think, a year now, and we're only just about to formally release the final official version of it. So those standardization processes actually take time. For the policy stuff, it's currently, so it's in place. A lot of work has been done by a German guy who works at JPMC in New York, basically because he's tasked to do that from his organization. And the group has, after several tries, sort of we agreed on this being the best proposal of all the different things that have been discussed. And now at the moment it's being cleaned up, so there's always a lot of glitches in such a large spec that need to be finally negotiated, discussed, and found a good formulation in the end. And from there, I think it will at least take another 3 months until we reach sort of beta state, where the thing is practically out and published, so it can be used and picked up. So JPMC does use it now. And then it will take probably another half year until all the formal steps and finalization and so on of the actual standards document is being there. So probably this is almost a year down the line until it's fully spec'd and published, but it is already available as a GitHub repo. Yeah, you probably find it on the dprod GitHub as well.
Thank you for the answer. I see Andreas has an answer, and question as well.
Yeah, no answer, just a question. Thanks for the nice presentation and the overview. I think it's really interesting and very important, in particular because, as we know, there's still a struggle of establishing enough semantics. And as we know, semantics is really important to actually to enable trustworthy AI. It is an interesting, for me, it's an interesting question. What's your estimation? How much of the task of the semantification of data did we already have done in the industry and other organizations? And what do you think, how much will it speed up as we have better tools right now?
Good question. So I see in different organizations very different approaches of how to get there. So in pharmaceutical space, they have been working very long on this, and they, well, also take a very careful approach, which is not necessarily fast. I see other people in other organizations using very aggressively AI tooling, also trying to sort of speed this up, which is a trade-off in quality and precision, but sometimes speed matters just more. So we're also moving in that direction. So the agent layer is in the roadmap for the next 12 months as well. So this is where things are going for sure, that more stuff is more aggressively being automated. As I said before, I think you can't outpace the fact that you need to essentially negotiate what you want. An AI agent won't tell you. And there are many questions that the organization needs to resolve. How much does better tooling help? I would say without good tooling, it's kind of hopeless task. The other day I talked to a former colleague who's in a research context doing similar stuff like Søren in the Netherlands. And she was also lamenting that they get a lot of funding to do all kind of work, but when it comes to funding for tooling, there is sort of a big hole. So it's a mindset. We now see this much more pop up in large organizations, which is very much due to the fact that with new central competency centers or even organizational top-level structures being installed for AI and data, there is suddenly somebody who's in charge and ultimately then also has a budget to make this happen. In previous years, all these ideas were around for a long time, but the major hurdle was usually that a lot of people in large companies says, I completely get it and I like the idea, but I have only budget to solve my problem and not do anything for everybody else. So the good thing is with AI also there is more central responsibility for the surrounding infrastructure, including knowledge graphs. So I think this will definitely speed up things. All these organizations are currently in a mode of learning because despite there being a vibrant academic ecosystem, the average enterprise organization doesn't have all that much knowledge about ontologies and semantic technology as of yet.
Can I add one sentence? And that the point of semantic packages is that once all the complexity has been resolved, either in totality or partially, you don't have to spend another time re-answering the same questions and so on. So that's what semantic packages will help speed up.
Yeah, I completely agree. But for example, I just talked last week to the head of AI of Ford Motors in the USA, and there was this kind of information like you never have enough in semantics, right? So that's why this kind of a huge question. They have invested a lot of things, they have invested in a huge stack, but still, after applying the AI technologies, they still come to the conclusion that it's not enough what they have done on the semantic side. So that's why there's always this kind of race, of course, but yeah, as we see, typically there's a huge gap. Thank you.
Thank you.
Okay. Any questions from the audience? If not, then thank you very much, Marcel and Nour and Marcel, sorry.